Today we're going to look at hobby motors, the tiny little motors that you can find around in things like electric toothbrushes and electric whisks, but also often shared in Arduino kits and other electronics kits. So these little motors are not going to draw many amps, and so they're safe for the Arduino. Once you get past a certain capacity, though, you really do need to offload the power and protect your Arduino by using a motor controller, which we'll look at tomorrow in part 2. So today we're just going to look at basic motor control. We'll control the motor with a joystick, and we'll control the motor with a temperature sensor. This is the basic motor control sketch, and we start with setting up the motor on pin 9 as the signal. We're just going to use the y-axis of the joystick, so we've just got to specify the y-axis, which we're using as A0. We start in the serial, the motor is an output and the joystick's an input. And in the loop, we read the signal from Y and we map it from 0 to 1023 to our output of 0 to 255, and then those are reported to the serial monitor, and we analog write to the motor whatever we've got back from the joystick, and then we have a small delay just to not overwhelm the serial. One of my motors here happens to have a little fan attachment, so I thought it'd be fun to use the DH12 temperature sensor, which is a temperature and humidity sensor, and control it by checking the temperature and setting the fan on if the temperature is above a certain level and turning it off if it's below a certain level. And this sensor provides us the resulting C in Celsius, so I can set it based on that. You can also obviously get it in Fahrenheit, but I think in C. So we use the Adafruit libraries for this. There are other libraries out there, but this is a particularly comprehensive one. So you have to go to your libraries and find it in the library manager. I can't type. So here we've got Adafruit Unified Sensor Library, and then you can include it. Mine is a DHT22, there are DHT11s, this just happens to be the one I've got. My motor is plugged into pin 9, and my sensor is using A0, and then we set up the DHT sensor with the sensor pin and the type. In the setup, we need to tell it to start, and it means it's going to start getting readings. We open our serial, and we set the motor to output, the sensor to input. Each time through the loop, it will check the humidity, and it will check the temperature using these built-in functions. If it has a problem, it will come back as is not a number, is nan. So we check to see if is not a number humid, or, which is these two pipe symbols, or is not a number temperature. If we get a problem, we output that we've failed, and then we hit return, which will start the loop again so we can try again. And then on the serial monitor, we're going to output the humidity and temperature. So again, if you're using the desktop IDE, you could plot those, so you could see a nice little graph. And then I say if the temperature's under 16, then we need to turn the motor off. And if the temperature is higher than that, then we output that it's warm and that we should set the fan on. And we're purely using the signal from the digital pin to output enough juice that the motor switches on. So this is very simple motor control. So as I said before, don't put a high spec motor onto these pins. It's not capable of providing that current. Only tiny motors can be used this way.